This is homework number 4, and I'm going to help you with problem number 4. Problem number 4, you're being asked to find the slope of the line passing between 2 points. And the 2 points given are 1,8 and -2, 3. It's always a good idea to label your points with X's and Y's so that you're keeping straight which value is which in the coordinate pair. Now I'm going to go about this 2 ways. The first way is graphically, so you can see concretely how to find slope. So I'm going to make an XY coordinate axis, and I'm going to plot these 2 points. They are 2 points on a line, because it's talking about the line passing through these points. So 1,8 over 1 up 1, 2, 3, 4, 5, 6, 7, 8. All my spaces are 1 unit, so I'm not going to label the axes. It's just understood that this is over 1 up 8. My other point, let's just label this for you, 1,8, is -2, 3. So from 0, 0, left 2, and up 1, 2, 3. -2, 3. And I grab my ruler, and this is the line passing through those 2 points. And we want to find the slope of that line. In order to do that, I'm going to draw a right angle following the grid lines between those 2 points, and I call this my stair step. And on a stair step we always have a rise and we have a run. Rises and runners on stair steps. The rise is 1, 2, 3, 4, 5 units, how much it goes up and down vertically. The run is from here to here, and that is 1, 2, 3 units, 3 spaces. Slope is rise divided by run on a graph, or the fraction rise over run. So my slope in this case is 5 over 3. And I can just leave it like that. I don't have to divide. I just leave it as a fraction, because it tells me a lot as a fraction how much the points rise and run on the graph of this line. Now we can also find slope algebraically using the slope formula. Slope, we usually use the variable m, is this formula. You take the y value from one of the coordinate pairs and you subtract the y value from the other. And so we can keep straight which y is which. We put these little numbers next to them. This will be the y from my second pair I've decided, and that will be the y from my first pair. That's not asking you to do anything. It's not like an exponent. It's just designating which y is which. And I'm going to divide that by, or put it over, fraction-wise, the x value from one of the pairs, subtract the x value from the other pair. So as you're working a slope problem, you're going to want to label your 2 pairs with who's going to be who. So my 2 pairs were 1,8 and -2, 3 again. And I'm just going to arbitrarily decide that this is my pair 1. So I'm going to call the numbers x1 and y1. And that's actually a sub. You actually say x sub 1, y sub 1, x sub 2, y sub 2. Now I'm going to pay very close attention to this labeling as I use this formula and plug in these values. So here we go. M equals y2. Let's go get it. y2 is this 3 right here. Be careful, don't choose x. It's the y values on top. 3, subtract. Now we're going to go get the y1 value. That one's right here. It's the 8. All over, here's my fraction bar, the x2 value. Here's our x2. That's a -2. Subtract, remember to subtract for slope, the x1 value, which is 1. Plugging in a 1. And then we just simplify that expression. 3 minus 8, again, if you're not sure of your integer operations, get your calculator out. 3 minus 8 is -5. -2 subtract 1 more is -3. Now a negative divided by a negative will always be positive, so I can rewrite this simplified as 5/3. Now this is the same value that I got graphically when I drew the rise and run. You're doing the same thing here. You're just asking yourself, how much does this point rise from 3 to 8? How much does it run from -2 to 1? Now one last thing. What if you arbitrarily decided that this is pair 2 and this is pair 1. Does it matter? Well, let me show you quickly that it doesn't. I'm going to rewrite these as this will be pair 1 this time, x1, y1, and this will be pair 2, x2, y2. Does it matter? Well, let's get our slope formula out again. We take y2, that's the 8 this time, subtract the other y value. That's the 3 this time, so it's backwards. We had 3 minus 8 before, now we have 8 minus 3. But the bottom is going to be backwards too. And we're taking 1 minus negative 2. This x minus that 1. On top I'm going to get 5. On the bottom, 1 minus a negative 2 is like doing 1 plus a positive 2. Add the opposite, and I get 5/3 that way also. So again, it doesn't matter which pair you label which, just as long as you keep your x's and y's straight.